Okay, ladies and gentlemen, if you take a look at this page, last class we talked about speeding up and slowing down with particles. Remember the monkey moving along the x-axis? Two questions. First one says, when is the particle speeding up? You get this graph. Second one says, when is the particle speeding up? And you get this graph. So what's the difference between the two questions? Alex? Yeah, so the first one, this is displacement. And on the second one, I'm giving you the velocity. And the way you're going to think about speeding up and slowing down is going to be different depending on which one you're given. Right? So displacement means how far away you are from a starting point, and velocity means how fast you're going and in what direction. So I'm going to be quiet for, I don't know, a minute or two. I would like you to get together with your partner, and I want you to at least think about these first. Make a guess at what intervals it would be speeding up on. Okay? So get together with your partner, go for it.
Why is your
I also don't know. It just looks like it's so ridiculous. That's my guess.
It's not speeding up. It's slowing down because of the loss of proportion.
Is the velocity on this graph listed?
I mean, really.
It's going so speeding up.
Are we in a good place to talk about it, or would you guys like a little more time? I do really like to have you guys think about the problem a little bit before I tell you the answer, because I think that the answer is more meaningful. Like, you're more likely to retain the information if you've actually thought about it first. So first one, any brave soul want to take a guess at where our particle is speeding up or slowing down? No brave souls here in first hour? Oh, I got a brave soul.
0 to 1.
It is 0 to 1. Yeah, it's this interval right here. How many of you right now are thinking like, oh man, I knew that answer. I could have been the brave soul. Yeah. All right. Kayla, you want to explain how you figured out that that's the one?
Well, if you take the derivative, like for example, if you drew a line, it's at the top there, it's about 0 there.
Uh-huh.
Then as you go further down, it's getting steeper and steeper.
I like that. So this is the one interval where the slopes are getting steeper. That's a really good way to think about it. Okay, if you look at any of the other intervals, 1 to 2, 2 to 3, 3 to 4, 4 to 5, on all those others, the slope is not getting steeper. It's either getting less steep or it's not changing. We feeling good about the first one? Okay, let's go to the second one then. This is the only time that it is speeding up is right there. Do you see how in the next interval the slopes are getting less steep? They're leveling off. And then right here the slopes are like the same. Yeah, Molly?
If the graph started, say just everything was moved back on the scale and it started at 0, but where the 1 is. So the first 1 to 0 wasn't there, then would the 1 to 2 be getting steeper because that's the steepest? Or
No, it'd be getting less steep because that's a pretty steep
so
slope.
there would be no speeding up on the whole.
Yeah, if you didn't have this, it would never be speeding up. It would be starting off going pretty fast in a negative direction,
Yeah.
and then it would slow down, and then it would go at a constant speed, and then it would sit still. Okay, let's take a look at the second one. Any brave souls want to tell us where we are speeding up this time? Alex, you're a brave soul.
1 to 2 and 3 to 4.
You got it. 1 to 2 and 3 to 4. Now, there's two ways you can figure this one out, and I would like to talk through both of those ways. Option number one is this. If it's speeding up, what do you know about the velocity and the acceleration? They do. Okay. So one way you could figure it out is you could say, since this is the velocity, velocity is positive, and then it's negative, and then it's negative, and then it's positive, and then it is positive. So I'm just looking at whether we're above or below the x-axis here. And then acceleration. For the acceleration, you want to be looking at the direction. So like right here, the velocity is decreasing through there, right? Do you guys see that? Okay, that tells us that the acceleration is going to be negative here and here. So velocity decreasing gives us the negatives. And then here the velocity is increasing, so positive and positive. And then in the last interval, the velocity is not changing. What does that mean for the acceleration? Okay. So if you do it that way, you'll find that right here and right here, we have the same signs. Therefore, those are going to be our intervals. There is another option for finding when it is speeding up when you're given a graph. And so I'm going to show you that second one. Remember the relationship between velocity and speed. That speed is equal to the absolute value of the velocity. So if you wanted to turn this into a speed graph, you could do that. You would just take this segment down here. What would you do with that? When you flip it, it goes like this. Ba-boom. Right? I flipped that up. And then ba-boom. And now it's really easy to look at the speed graph. This is the speed graph up here and say, oh, it's on its way up right there and right there. Notice that those are the exact same two intervals that we found using the velocity acceleration method. Okay. So for Friday, it would be really great if you could think about speeding up in both of these ways. I think that both of them are going to show up. And by I think, I mean I know, because I wrote the test. Sure. And let me just kind of close the door on this one first. Any other questions on this one? Okay. Speeding up means that your slopes are getting more steep. So for instance, if I'm the monkey on this one, I know that my displacement is getting smaller, so I'm moving backwards. And since it's getting steeper, that means that I'm going like this. Okay? So you just look at where those tangent lines get steeper. That's where it's speeding up. Okay. Anything else for the good of the group? Okay, I'm going to stop hitting record right there.